Yeah, Bismillahirrahmanirrahim. For today, we are looking for Vienna development method. Okay, for Vienna development method is one of the way informed method that we can measure, we can use in a formal method. Okay, and then other than that, we are looking also for Z method. Basically, VDM is formal mathematically oriented method for specification of system and development of software. In most cases, formal specification language fall into two classes, algebraic language and model-oriented languages. And VDM is model-based. Okay. Saya lukis sikit. Okay, basically we have VDM. Okay, this one VDM is model-based. Model-based method lah. Okay, in general, formal specification that we learned last week. Formal specification have two classes: algebraic languages and model oriented. VDM is model based or model oriented. Okay, what is VDM? Okay, VDM is one of the longest established formal methods for the development of computer-based system. Okay, basically, it is way back in 1970s. It is introduced by IBM Laboratory Vienna that grown into a group of technique and tools based on formal specification language. And then for the first one, they introduced the VDM SL. It is extended form, and then after that, we use the VDM++. This one is based on object-oriented. Boleh baca ke saya punya tulisan ni?
Boleh.
Ya, Doktor.
Ya, Doktor.
Okay. Okay, and then this one is to support for the commercial and academic use. Okay. For analyzing model, including the support for testing and proving properties of model, and also generating program code from validated VDM model. Basically, this one is a tool, VDM. Uh, for testing and also proving properties. Okay, and then VDM continue. The VDM SL and VDM++ have a syntax and semantics are described at the length of VDM tools, language manual, and available in the text. It also contains in ISO standard that have a formal definition of the language semantic. Basically, this one is based on ISO standard. Okay. VM have a syntax. We have a syntax and semantics. Okay. Okay, this one basically for the ISO standard. Okay, wait. Okay, sorry for the interruption. Okay, and then this one is basically for the ISO standard. Okay, and then uh, ISO also define interchange. Basically, this one is using the ASCII syntax. ASCII syntax. It consists of some of description. Okay, basically they have a type name in our model. We begin with a capital letter. This one is a general syntax. Okay, this one is general syntax. Okay, and then function name always begin with a capital letter. Okay, and then formal parameters and object also always in the lowercase. Okay, lowercase letters. And then all functions specific to INS have a name ending at NS. Similarly, name of EC specific function and in at EC. Okay. Okay. This one is uh, the basic data type. Okay, and then for the VDM's syntax and semantic, VDM-SL and VDM++ syntax and semantic are also described at length in the VDM tools. Available in the text or string format. Okay, and then we have some basic type. Okay, we have Boolean data type. We have natural numbers. Later we see this one. And then the ISO standard contain a formal definition of language semantics. Okay, that have that represent the data of the model system. Each type definition introduces a new type name and give a representation in terms of the basic terms or basic types that already been introduced. For example, later we see that one in detail. Okay, and then VDMSL model is a system description given in the terms of functionalities performed on the data. It contains a series of definition of data type and function or operation performed upon them. Okay, this one VDMSL. VDMSL is basically is more on a system description of the functionality performed on data. Okay, this one is basically more on the data functionality performed on data. Okay, when you talk about performing on the data, okay, it includes a basic data type lah. Basically, you can see here Boolean data types. Okay, NAT for natural numbers, including zeros. Okay, and then we have natural numbers excluding zeros, and then we have integers. Okay, and then we have red for rational numbers, real for real numbers, and then we have characters. We have a token, structureless token, and then we have a code, code open code and close quote. Okay, and then for data type are defined to represent the main data of model system. Basically, each type definition introduces a new name type, new name type based on the domain, and give some of representation in terms of basic type that already being introduced. For example, we have type modeling user identifiers. Here we have identifiers for login management system. This one is for login management system that have a type and user ID as a natural numbers. Okay, so far do you have any question? Ada soalan ke? Dizian okay?
No,
Yes?
semua okay.
Semua okay?
Ya.
If you have any question, you can ask. Okay. Okay, for manipulating values that belonging to the data types, data type yang we look this one is basic data type. Okay, operator are defined on the values. Operator are defined in values. Thus, the natural number addition, subtraction, and etc. are provided. Okay. Okay, and also we have Boolean operators such as equality and inequality. Okay, we have Boolean data types. Okay, and then the language does not fix the maximum or minimum representation number. This one is not fixed. Okay, not fixed. Uh, they don't have a minimum or maximum range. This one basically for real numbers. Real number. Okay, and then they have some of the constraints are defined whereby they are required in each model by means of data type invariant, including the Boolean expression that representing the condition that must be respected by the all element. Okay, for example, if we have the user identifier must be no greater than 9,999 would be expressed. Okay, if we have 9,999, okay, 9 pun dah tak betul. Okay, 9,999. We can express like this. That is less than or equal to. Okay. And then we represent the Boolean operator on natural numbers like this. You have a user ID, and then we have a user ID equal to natural number, uh, and then we have invariant user ID equal to user ID UID less than or equal to 999. Okay, boleh Syaira boleh? No Syaira?
Ya boleh.
Boleh. Oh, ada dua, Nur Syaira dengan Nurul Syaira. Okay, since invariant can be arbitrarily complex, invariant, INV stand for invariant. Okay. Since invariant is very, it's like, okay, can I explain a little bit? Okay, we have invariant. Okay, invariant. Okay, can be arbitrary complex logical expression. It's a very complex expression. Okay. So uh, okay, membership of defined is type limited only for those values satisfying the invariant. So we can use the membership. Okay, we can use here as a membership. Okay. Membership limited to those values satisfying for the invariant. This one for satisfying for invariant. You need to satisfy. Uh, Type correction in VDMSL is not automatically decidable in this all situation. Okay, this one is for VDMSL. The other basic type include the character. Okay, the other basic type is we have CHA is for characters. Okay, character. Also, in some cases, the representation of the type is not relevant to the model purpose and would be only add complexity lah. So, if we go by the invariant, okay, and then express the complex expression, this one might be add some of the. Okay, this one might be uh, uh, add complexity. This one add complexity. Why? Because every time you need to express and then express and then satisfying the membership of the invariant. Okay, so uh, uh, for, for manipulating the values belonging to data type, the operators are defined on values so that the natural number in addition, subtraction, and etc. are provided as Boolean operators. Basically, they are measured as equality or not equality, not as invariant. Okay, so the language does not fix a minimum and maximum representable number. This one I explained. Yeah, so requirement that user must be no greater than 9,999 would be a Boolean operator lah. Okay. Okay. So specific name values are required lah. Okay, for example, we have to model the traffic signal controller. It might be consider the values. We have amber, we have red, we have flashing amber and green. What is amber? Amber ni color apa? Siapa tahu amber ni color apa?
Merah oren.
Dia antara merah dengan oren. Okay. Combination midway between colors of yellow and orange. Dia panggil amber lah. Dia bukan, it's not yellow it's not yellow. Okay. And then okay, so after all of the complexity that we seeing, we have a data type and then we have an invariant. Okay, and then we add complexity. Okay, we add more complexity. VDMSL is an informative annex that contain different structuring principles that uh, might have some of the problem is complexity. Okay, and then this one follows the traditional approach. Okay, for first one we have a module naming or naming convention. First one, each module is syntactically started with the keyword module followed by the name of the module. This one is a very traditional approach. Okay, followed by the name of the module. And then at the end of the module, keyword and is written, followed again by the name of the module. Okay, this one is very traditional. And then number two, we have importing. Importing, we need to import some of the definition because of what? Because it have complexity. Complexity. We need to start off with the keyword import, okay, and followed by a sequence of import from different module. It is not object oriented. This one is more likely is based on the structured programming module. Okay, and then the module signature can be either simply be keyword that indicating all the import signature that this one is for importing or for exporting. And then the import signature varied, including for the types, values, function, and operation. This one started with the corresponding keyword. Okay. In addition, we have optional type. Okay. For this type, we need also to use keyword struct if one to wish to get access to the internal structure of the particular type. Okay, we have here, let's see, we have functions. We have function here. Okay, inside the function, this function, okay, we need to, when we want to access this function, let's say we have member A, member A, okay, you need to use the keyword struct, okay, struct A, okay, in order to access membership privileges, okay, membership privileges that you can assign for specific type, values, function, and operation, including the Boolean data type. Okay, and then after importing, number three is exporting. Export. We want to export the values. The definition from the module that have importing from the other module that have the access that exported by uh, the usage of the keyword export, followed by export module signature. The export module signature can either be simply consist of keyword or as a sequence of export signature. Okay, more exotic feature. More exotic features mean this one is not available. Not available because of the exotic characteristic. In earlier version of VDMSL, the tool supported for the parameterized module and also instantiation of each module. However, this feature was taken out around year 2000 because of the complexity and because of the uh, we want to use every stages in the VDMSL. For example, if you want to uh, import, you need to have the yeah, import signature. If you want to export, you need to have the export signature lah. This one is complexity is not automatically decidable lah. Okay, so So in VDM++, this one is based on the object-oriented. This one is enhanced version of VDM SL. In VDM++, is using object-oriented approach done by using classes and also multiple inheritance. Okay, the key concept for VDM plus plus. Okay, for VDM plus plus is the we have a normal form. Okay, we have classes, we have inheritance, we have access modifiers. For example, we have a private, public, and protected to access the memberships. Okay, of the functions. Okay. Okay, for the VDM SL, they have a structured VDM SL. We have a structured template. Ada soalan ke setakat ni? Muhammad Zamrin boleh ke?
Boleh doktor, boleh insyaAllah.
Okay. You slow down and slow and steady. Okay, in VDM SL, this one is basically is not object oriented. Okay, this one more on structured. We have okay, we have types. Okay, and then we have values. Okay, types. How to write the types? Okay, we have some types. Okay, some. Okay, and then we have values. Okay, and then we have constant name equal to constant type equal to some values. Okay, and then after that, we state system name of, and then dot. We have n. Okay, this one is VDMSN. It's a conventional approach. Conventional approach for Vienna development method. Okay. Okay, and then here is basically is a extended version of VDM SL. This one is VDM plus plus, which including the object-oriented approach. Okay, later we see the the case study, case study. And then we have functional modeling in VDMSL. Function are defined over the data type. Okay, like this. Function are defined in the data type. Okay, we have some type and so on. Okay. Support for abstraction required. It should be possible to characterize the result for the function. For example, a function square root for calculating square root for natural number. We define as a square root, x as a natural number, r for real, and then we have a uh, pre and post condition. Pre and post condition. Okay. Okay. Here post is r multiplied by r is equivalent to x. Okay, post condition does not define the method for calculating the result of R, but also it provides the properties. Because in VDM, we want to measure the invariant. So we don't want to express or to indicate the result, but the indication is clearly based on the states. Okay, and then the specification of above will be satisfied, for example, by a function that return negative root of 4, but the positive root of all other is defined as a valid input. Okay, note that the function in VDMSL are required to be deterministic. So the function satisfying the example specification must be always return the same result for the same input. Okay, this one for the input. For the input is return the same values. Why? Why returning the same values? Because for functional modeling, it can hold the properties, the properties. Okay, this that's why it it uh, correspondence between two valid inputs. Okay, so in VDMSL, we want to introduce the state-based model. What is state-based model? State-based model basically is the model that based on the state. Okay, for example, here we have a state register. We define as natural numbers. Okay, natural number here. Okay, this is a useful ability in many programming languages. So a similar concept exists. Instead of function, operation are used to change the state variable. It's also known as a global variable. Okay. In object-oriented, they cannot use to change the state because in VDM++ is more on the more on the object-oriented, more on the output oriented based model. This one is more on the state. State is mostly used to define the precondition of the schema. Okay, and then in VDM++, this would instead be defined as instant variable. Okay, this one is we have state register of some state register as a natural number. For this one is we use the instantiation of the object. Okay. Okay. For the summary, VDM++ is a large language with many constructs. It's more complicated languages that maybe appear exotic compared to normal general purpose programming languages such as object-oriented approach compared to object-oriented approach. Yeah, and then we must remember, however, the invent of VDM is not to program, but to specifying a model of the program. Okay, we have uh, we want to model, and then for the functional modeling in VDMSL, function modeling are defined over the data type defined in a model that we look into the main mechanism. For example, we uh, we have take a look for the square root function, and then we have a post condition. Okay, and then the level of abstraction is necessarily higher than a general purpose language. We can specify the model using a high level construct, okay, such as set, map, and implicit function. This one we use a lot. Okay, we use a lot. And then this one without having to worry about how they will be implemented. Okay, for example, I give you example. Okay, this one to add on your knowledge about the VDM SL and also for the VDM plus plus lah. Okay, we have incubator monitoring system. No? Okay, in the VDM SL, in VDM SL, you must include some of the operation type. Okay, we have this one VDM SL. First, for the incubator monitoring system, we record the increment, and then secondly, records a decrement, and then we also read the operation that reads the value of temperature. Okay, here in VDMSL, please remember, VDMSL, you need to record the pre and post condition. So we record the increment and also we record the decrement. In VDM operation, it's possible to access the state either by reading or writing the data or both. Okay. And then in the VDMSL, operation consists of four sections. We have operation, we have external, we have precondition and postcondition. Okay, operational header, external clause, precondition and postcondition. Okay. Okay, later for this one, we specifying a function explicitly by using the VDM plus plus. Okay, for this one, we specifying a function by using VDM plus plus. Okay. Okay, later we see for the specifying the function by using VDM plus plus. This one you are using Z notation. Z notation. Next week we are looking Z notation, and I give to you for the first assignment. Okay, for this one, do you have any question? Boleh ke? Do you have any question? Ada ni Nurul Hafifi, Nabilah ada angkat tangan tu nak tanya apa? Does incubator monitoring system here count as an implicit function or a technology, and may I know what are some example of implicit function Oh, kamu tak ada ni Tak ada apa? Mikrofon. Okay, implicit function is function that defined by equation that relates one variable into another. Okay, considered as a value of the function with the other considered as the argument. Okay, incubator monitoring system here count an implicit function or technology. This one is for this one. This one is not counted as technology. It's counted as implicit function. Okay, because this one is defined by the equation to relate the variable incubator monitoring system. Okay, we want to search the relation for the VDM SL and VDM plus plus. Okay, is it okay? Nura Fifi, boleh ke? Diam dah.
Okay. May I know implicit functions apa?
Implicit function untuk apa?
Maksud implicit
Implicit
functions.
implicit function ni okay, implicit function mathematic equation lah. For example, we have y power of 2 plus xy equal to 0. Okay, we want to find out the function. Okay, function fx y z is equal to 0. Okay, this one is one variable is dependent on other two variable is implicit function. Okay, it's a mathematical function. Mathematical function. Okay, this one for in VDM SL or VDM plus 5 is the implicit function that we want to relate one variable to another variable. For example, we want to record the increment, we want to record the decrement, we want to read the value of the temperature. Okay, this one is just case study lah. Ni case study. Okay, that to depict or to show the pre and post condition yang saya bagi tahu tadi lah. Okay, we have a pre and post condition. Okay, mana tadi VHDM class structure. Jadi dia kena ada tu lah tadi ada four main four main requirements. We want to have the uh, operational header, external clauses, precondition and postcondition. Okay, here, okay, another slide. Okay, in the VDMSL, we must have four sections. First one is the operational header. Later we see this one in Z notation. Second, the external clauses. Thirdly is a precondition. And lastly is a postcondition. Okay, ada soalan lain? Boleh ke? Ada apa-apa soalan?
Dari saya
Ada.
tak ada.
Siapa? Arif. Arif Aikan, boleh ke?
Boleh, tak ada soalan, tak ada soalan.
Zamrin, okey ke?
Okey doktor, okey.